So more area and volume questions dealing with water. We have a flat roof in a garage, 11 meters by 10 meters. We have another meter here. We have 5 millimeters of rainfall, so we better have a look at the units here. And we centimeters, so 3 different units mentioned. Find the volume of this rain in centimeters cubed. Okay, so 10 meters. A meter is 100 centimeters, so 10 meters is 1,000 centimeters, and 11 meters is 1,100 centimeters, and 5 millimeters is 0.5 centimeters. So just be careful when you're multiplying these out that you get the correct units here. So what have we got going on here? We have 1,000 by 1,100 by 0.5 or 1/2, and that's going to give us 550,000 centimeters cubed of rainfall. Was it on a day, during a certain week, and a week? The rain is caught by gutters and brought into a cylindrical barrel, very environmentally friendly, of diameter 1 meter. So we know we need the radius 50 centimeters if we're dealing in centimeters. By how much will the depth of the water in the barrel rise during the week? And use pi as 22/7. So, well, we have the volume of water that has fallen. It's 550,000 centimeters cubed. So we have a cylindrical barrel, so pi r squared h is equal to this 550,000. So we put 22/7 in for pi. We know that r is 50 centimeters. We're dealing with centimeters. So 50 squared times h is my 550,000. So let's multiply that by 7. Multiply that by 7 and divide by 22 by 50 squared, and we're going to get h to be, does it work out evenly for us? And it works out to be 70, and we're dealing in centimeters, so the height of the water in the tank is going to rise by 70 centimeters. And then second question in this video, a test tube consists of a hollow cylinder, and we have a diameter down the bottom here, diameter 3. So once you see that, you write r equals 1.5 centimeters. We have our height of 8.5, so this must be 7 from here to here, due to the fact this is the radius from the middle down to the bottom here. So what are we asked? Find the capacity of the test tube when full in terms of pi. Okay, let's look at the volume of the cylinder. Pi r squared h. Any information about pi in terms of pi? So we have pi by 1.5 squared by 7 gives 15.75, 2.25 by 7 pi. The volume in the hemisphere is equal to 2/3 pi r cubed, which is equal to 2/3 by 1.5 to be cubed by pi. So that works out to be 2.25 pi, and if we add 15.75 pi, 17 and 1 is 18 pi for the capacity of the test tube, and that's in centimeters, so centimeters cubed. And then the depth of liquid in the test tube when it's half full. Okay, so we need to get half the volume is 9 pi is half the volume. So then we know that this guy down the bottom is going to take up a certain amount of it. How much is he going to take up out of it? He's going to take up the volume of the hemisphere, which is 2.25 pi. So if I take away 2.25 pi, I'm going to get 6.75 pi. So we can say that 6.75 pi is equal to the depth of water in this part up here because the hemisphere is full. So that's a cylinder of pi r squared h. My pi's cancel. My 6.75 stays there. That's equal to r 1.5 squared by h, and 1.5 squared is 2.25, and 6.75 over 2.25 is h, so h in this case is 3 centimeters. So it's 3 centimeters up the cylinder, and it's another 1.5 off the bottom, so it's 4.5 centimeters from here, starting point, to wherever 4.5 is up there.